we factoring expressions? Yes, factoring like you did back in IM2. Okay, so the method that I use is factor by grouping, which is what you did if you had all of those other IM2 teachers. So for our first problem, I have factoring when a equals 1, r squared minus 10r plus 9. What is a? How do I figure that out? Okay, so I make a t-chart. Let me backtrack, sorry. So when we have a quadratic equation or an expression, it's written in this form. Is that something you remember? You've seen that before? The three terms are a, b, and c. So this means a equals 1, which just means I have 1 right here, okay? So when I make my little t-table, what goes on the left side? It's our multiplication, which is what terms? A times c. It's a times c. So what is a times c here? It's 1 times 9, which is... And then what goes on the other side of my table? Addition to my b term. And what is my b term? Negative 10, okay? Do you follow so far? So I need to figure out what two numbers multiply to 9 and add to negative 10. What is that? Negative 9 and negative 1. Do you agree with that? Okay. So negative 9 plus negative 1 works. That equals negative 10, okay? So the way I like to rewrite this when I'm factoring is my first term and my last term stay the same. And now I'm going to put my new factors in place of this minus 10r, okay? So the two numbers I found were negative 9r and negative 1r. Okay, so for those of you who didn't do this, do you understand where those numbers are coming from? Okay, they come from my little t-table. And some of you set that up using an x. It's just another method of writing it. So I know Jensen doesn't split it down the middle. I like to because apparently we can't split 4 in half. So split it down the middle because now it's in our two parts. Okay. So right here, I need to find the GCF for r squared and negative 9r. What can I factor out of these two numbers? What comes out? An r, good. So my r comes out front. You all sounded like pirates. What's left over? R minus 9. Do you agree with that? Is that okay so far? Now, the other thing that I like to say, or I like to do, is I know this part is always going to be, it's going to be the same over here. It has to be the same because it's a factor, okay? Now, I don't have that right here. I have a negative 1r and a positive 9. What can I divide by that gives me r minus 9? Yeah, I have a negative 1 because negative 1r divided by negative 1 is positive r. Positive 9 divided by negative 1 is negative 9. So this is the number that comes out here. Okay. Now, to write this as my set of factors, I have r minus 1 as one factor, and r minus 9 is my other factor. Okay. I'm going to do the next we're going to do the next example, okay? So now I have a is greater than 1. So a is something other than 1. What is a this time? 5. Good. So we do the same thing. We're going to set up our t, and really the t doesn't matter so much as you need to organize your thinking and figure out the factors. This is just an easy way to write it. So what is a times c for this problem? 5 times 8, which is 40. Good. And what is my b value? 13. Okay. So this goes here, and then this goes here. So what multiplies to 40 and adds to 13? 8 and 5. Do we agree with that? 8 times 5 is 40. 8 plus 5 is 13. So that's kind of like our little diamonds that we were doing on our homework last week. Okay. So I have my first term, my last term, and I'm going to fill in my middle terms, which are plus 8m and plus 5m. Then split it down the middle. What is the GCF of my left side? 5m comes out of 5m squared and 8m? It's just m, okay? If you wrote your factors differently, it would be 5m. But mine's a little bit different from yours. I can only take out an m from here. What's left? 5m plus 8. Okay? So I know my right side is also going to be a 5m plus 8. But what is the GCF? What can I divide out from both of those terms? Do they have a GCF?
No.
Not that I can see, but there's a number that is always a GCF. 1. And what kind of 1 is it? A positive 1. So I really want you to focus when it's a positive 1. Write plus 1. Because I saw you all in IM2 when you'd come to tutoring, you wrote just 1, and then you did some weird thing. I don't know what it was you did. But when it's positive, you have to write the plus sign. Okay, so I have m plus 1 as one factor. Whoops. And 5m, that's the wrong color. That's not okay. 5m plus 8 as my other factor, and that's my answer, okay? Okay, so now we're going to do another set, kind of like the other one. Do you want me to try this one with you, or do you want to try it yourself? You want to try it yourself? I'll go through it, but can you try it yourself first and see what you can do? Okay, I'll give you 2 minutes. You can work in your groups. Do the first. Okay, so for my first one, we have what multiplies to negative 16 and adds to negative 15. Negative 16 and positive 1? Good. So I have 2x squared minus 16x minus 1x minus 8. My GCF of the left side is what? 2x. Then I have x minus 8. Is that right? And then, wait, did I do? Oh, sorry, it's a plus 1x. That was my bad. Was that the mistake? You were like, what are you doing? Okay, now I know my other factor is x minus 8. So what's the GCF? What number goes into both of those terms? 1. And what kind of 1 is it? A positive 1. So that means my factors are 2x plus 1 and x minus 8. We get that? We're pretty successful? Okay. Now on the next one, I saw... Yeah, okay. Question? Or are you just copying?
Yeah, question.
Yes.
Why for this one? You took the numbers of DCF as last one.
What do you mean?
Okay. The one we do the 5n.
Okay.
Why did you take 5n out of parentheses, but you took 2x out of this one?
Because 5 doesn't go into 8. On the way I did it, that factor that was with it was an 8, not a 5. So if you had your factors flipped inside, it would have been. But I'm just going to look at whatever number goes into both of them, and it won't always have a numbered GCF. Okay? And I think there's a couple examples where that happens. Now for C, I need to figure out what multiplies to 63 and adds to 24. I don't know. I don't have a calculator. I can't figure this out. So I know that 63 is 9 times 7, right? You should know that one. And that was my A times C. Now, I'm going to break 9 up. What goes into 9? 3 and 3. Okay. So I know 63 is 3 times 7. But I know that 9 and 7 don't add to 24, do they? Can I use any other combination of these factors and get that to add to 24? So I know 9 times 7 doesn't work, right?
3 times 7.
So I have 3 numbers. Can I multiply them together in any other way? 21 and 3? Does that work? Is that what you guys were saying? Good. Okay, so I know 21 times 3 gives me 63, and I wouldn't have thought of that. That's not in, up to my 12 times 12. I don't have that memorized. But I know what the prime factors are, so I can figure out what the combination is. And 21 plus 3 is 24. So I have 9m squared plus 21m plus 3m plus 7? Is that right? Okay. So what's the GCF between 9m squared and 21m? M is 1, and then 3. Okay, so 3m can come out, and I'm left with 3m plus 7. Okay, because I divided this out, that became 3. Divided this out, that became 7. Okay, now here's where I think your question was. Right here on my right side, 3m plus 7, is there a number that goes into both of those? No, it's kind of like with the 8 and the 5. So instead, I know I have 3m plus 7, and that's what I need. So what is the GCF that comes out? What kind? Positive 1. So I'm going to write a plus 1. So that means my answer is 3m plus 1 times 3m plus 7. And that's my answer for this question, okay? Does that make sense? Okay. We're going to move on. Slight work. Can you try A for me? Can you try A for me, please? Okay, let's talk about this. A lot of you have gotten pretty far into it. I'll wait. My factors are 4 and 4, yes? Okay. So I have 16w squared plus 4w plus 4. Whoops, that is not a 4. 4w plus 1. Am I good so far? Okay, good. And what is my GCF on the right side? 1 positive. Okay, so that means my answer is this. Is that the only way to write this as an answer? No. I can also make it quantity squared. Those are equivalent. Will I mark you wrong for either of those answers on a test? No, I won't, because these are equivalent. These are equivalent. This is a little bit more simplified, and that's how I would notate it. But both of those are equivalent, and I will take either of them on a test or a quiz, okay? Now, on B, I told you to be careful and look at it first. I have a GCF to begin with, because that's the first thing we always look for. Is there a GCF from the beginning? So what is the GCF here? 2, because they are even. It's not 4, because 4 doesn't go into 34 or 6. So 2 comes out, and I'm left with 10y squared minus 17y plus 3. Now I can factor. So what is a times c? 10 times 3, which is what? 30. And what's my b value? What do I add to? Negative 17. Okay, so 10 times 3 is 30. Is 10 plus 3 17? Nope. So we're like, Miss Audette, I don't know the factors again. So if we break it up, you should have gotten 15 and 2. Is that true? Okay, now, does 15 plus 2 give me 17? No, what's missing? They are both negative. So that means that I have still my 2 from the beginning. It's going to follow me through the whole problem. Then I have 10y squared minus 15y minus 2y plus 3. Is that okay so far? And now from here, we're just going to finish factoring. So I have 5y times, that looks more like a 6. Let's fix that. 5y times 2y minus 3. Then I know this needs to be 2y minus 3. So what is the GCF? -1. Good. I'm going to put some brackets around this and bring my 2 back down because I don't want to forget that in my answer. So I have 5y minus 1 times 2y minus 3. And am I done? Is this correct?
No, you said 2.
I forgot the 2 like I said I was going to. So you need to have that 2. This is the correct final answer. If you forget the 2 on a test or quiz, will you get full credit? No, you will get partial credit because I do give partial credit on all of my tests and quizzes. But the 2 is part of the answer, which is why I write it in every single step. Okay, we're going to do another one. Another one. Okay, we have 7r squared plus r. On the previous problem, what did we have to do from the very beginning?
Multiply the...
At the very first step, what do we have to do first?
Add 0.
Let's go back to it because we forgot. It won't go back. GCF, thank you. We had to find the GCF. Does this have a GCF? Does it? It's what? Good. Okay, now again, does the greatest common factor have to be a number? No, it can be a variable too. So I take out the r. So this leaves me with 7r. This one divides out, becomes 1. Can I factor that any further? No, that's my answer. And I know a few of you have said, what's that thing with the 0 and we equal it to 0? Do you remember setting it equal to 0? That's when we're solving. We're going to do that tomorrow. So we're going to do some more factoring. Yes. Okay, so do you see how they both have an r? That's the GCF. So I divided it out in red. And I'm left with 7r. And then r divided by r is 1. And that can't be factored further. So that's the final answer. Okay. I'm going to give you a couple more now. Okay, can you try these two? I'll give you 5 minutes. I'll give you 5 minutes to try these two, please. 5 minutes. Only 5 minutes because we only have 10 left. Thank you for helping each other. Okay, on the first part, bless you. On the first part, what's my GCF? 6. Good, 6. Some of you found 2, but then you were like, wait, another one goes in. And then 3 went in. So if 2 and 3 go into a number, 6 is also divisible. So I have, is that true? Okay, what multiplies to -4 and adds to +4? -2. Wait, hold on. Did I switch? Okay, sorry. Let's try this again. What multiplies to +4 and adds to -4? My bad. -2 and -2? Is that true? -2 times -2 is +4, yes? I wrote it wrong the first time. I'm sorry. Because I looked at one of your papers and you had it written right before I walked up. Okay, so I have 6 times p squared minus 2p minus 2p plus 4. Is that true?
6 is on the outside.
6 is on the outside from here. It just has to follow me through every step. I bring the 6 down. Okay, so I have p times p minus 2, and my other GCF is -2 times p minus 2. And 6 is still here? Yeah? Am I right so far? Now that I fixed my earlier error. So that means my answer is 6 times p minus 2 squared, right? Is that true? Or p minus 2 times p minus 2. Over here, divide by 3. So I have a squared minus a minus 12. So it multiplies to negative 12 and adds to negative 1. I have 3 more minutes, so please focus. Well, it multiplies to negative 12 and adds to negative 1. Four and 3.
4.3. Yeah, that's what I said.
Negative 4, positive 3. Yes or no?
Yes.
I know you're about to go to lunch. Just focus, focus, focus. I have a squared, and I have 2 more after this, so let's stay focused. Plus 3a minus 12. Did you do this? So I have a times a minus 4 plus 3 times a minus 4. Is that true? So my answer is 3 times a plus 3 times a minus 4, yes? Now I have 2 last very short ones, okay? Gotta move on. Come back and watch the video tonight if you need it. Okay, so on this last one, what is different about these two versus all the other ones I've done? There's 2 terms. It's missing the middle term, the B term, okay? So, when I see that, these are perfect squares, and I have subtraction. That tells me I'm going to do a difference of squares. So the way I think about this is square root my first term, which is what? What's the square root of 9m squared? And square root my second term, so the square root of 49 is... And now let's go back. What is the square root of m squared up here? So we have 3m, actually. So the way I answer this problem is write 2 sets of parentheses. Write my first term. Write my second term. And then plus or minus. That's the answer. Can I do one more with you? Just like it? On the second one, let's focus again. Then, if that was confusing, we'll watch the second one. I have a GCF. What is it?
Y.
It's y. So that means I have y times 64x squared minus 1. Yes, because y divided by y is 1. What is the square root of 64x squared? Hold on. Hold on. What is the square root of 1? So that means I have 8x minus 1 plus 1. And what am I missing in that answer? My GCF, my y. Okay, thank you. Make sure you do your homework. Have a nice day. I will see you all tomorrow.